Okay, so now let's try problem 1040. Okay. So let me read out the problem. It says water from a fire hose follows the path shown in figure P10-40. Determine the velocity of the water as it leaves the hose. So we got to find the initial velocity based on the information given in the figure, and this is the figure. So we have to find the initial velocity, and then this distance is 20 meters up to here, and then the total height is up to here, it is 6 meters, here to here is 50 meters. So again, we divide the problem into a vertical component and horizontal component. And for the vertical component, let's find the velocity in the vertical components first. Okay, so what are the things we know? Initial velocity in the y direction, vertical direction, we don't know. Final velocity, right, we know, because when the ball reaches the apex, the very top, right, its vertical velocity is 0, so we know that, and the distance at that point is 50 plus 6 is 56. Sy is 56 meters, and of course A is equal to G is equal to 9.81 meter per second square. We apply the formula v square minus u square is 2gs, right? And then what do we do? The final velocity is 0 minus u square. Of course, these are all y, is equal to 2 times negative 9.81 times 56 meters. Okay, so the negative, of course, the negatives get cancelled, so uy comes out to 33.13 meters per second. Okay. All right, now what do we have? We have the initial velocity, the y direction of the, we have this part. Now we need to find this, so that's u, uy, ux. We need to find ux. Now we take this vertical velocity and try to use that to get to obtain the horizontal velocity. How do we do that? We go through time. So that means from here we find the time, and then from time we use this 20 meters, and then from that we can calculate the, using time and distance, we calculate velocity. All right, so to find time, what do? We say, okay, to reach a height of, so here, how long does it take for it to reach a height of 50 meters? And you might say, why do we need the time to reach 50 meters? Because when it reaches the height of 50 meters, then that is when it has reached a horizontal distance of 20 meters. Right? If we find the time to find for it to get here 50 meters, that is the same time it has taken to reach 20 meters, and 20 meters in this much time will give us ux. Okay, so we use s equals ut plus half gt square. And please don't mind, I use a and g in these problems where there's gravity involved. I use a and g interchangeably, as I've written here. So you can write at square or gt square. So 50 equals initial velocity, right? So we got that as 33.13. 33.13 times time plus half 9.81 times t square. Okay, So once you apply the minus b plus or minus b squared minus 4ac formula, right, you move things around, and then you apply that formula, you get the value of t as, I'll leave that as a practice work for you. The value of t is 2.27 27 seconds and 4.49 seconds. And we've discussed in the past why do we get two values for t. Which one do we use? Look at the trajectory. It goes like that, and then it's like this. Okay, that's where that wall is. Okay, so this is 50 meters up to here. The ball, or sorry, in this case the water reaches the height of 50 meters two times, one on the way up and one on the way down. So it reaches the 50 meters first time at this time. Time is 2.27 seconds. That's when it is here. And then at 4.49 seconds, it is here. Okay, so this is the time. This is the time we need, because that is the time it takes to also cover 20 meters. Okay, so distance is, right, ux times time. Distance is what? 20 meters as per the figure. Ux, we gotta find out. Time is 4.49 seconds. Right, so you get ux is equal to 4.45 meters per second. So you have ux here, and then previously we got uy. So from ux and uy, right, ux, uy, 4.45 and 33.13. Okay, so when you do square root, u is square root of 4.95 square plus 33.13 square, you get 33.43 meters per second. Okay, and then the angle is theta is tan inverse the vertical component 33.13 divided by horizontal component. Right, so theta is equal to 82.28 degrees. Okay, so to recap, we use this formula to find the vertical velocity. Okay, and here we use 56 because that is the point at which we know the final velocity. We don't know the final velocity at 50 meters, right? We don't know the final velocity at 50 meters. So we will use 56 because 56 we know the final velocity, which is 0, because it has, when the ball or water it reaches at the very top, its final velocity is 0. So from that we can calculate the initial velocity. Of course, this is all vertical. This is all vertical. We found the final velocity, right? And then we found the initial velocity, and then we use this formula here, right, using this height, saying at what time does it reach this height. Okay, at what time does it reach this height? And that's what we found. And we could use this formula now because we know the initial vertical velocity, right? So we know the initial velocity. That is why we could use this formula. Before that we could not use this. Okay, before we couldn't use this straight away because we don't know u. So we find uy. Sure, you can write uy here. You can write u. So we could find the we can find t here. We could find t here because we know the initial velocity. That is why we could not start off with this formula. Okay. And then once you find the t, we know that we get two values of t because it's a quadratic equation, and we use the second value of t because this is the second time in the descension. That means while the water is coming down, or the ball is coming down, that is the time we're interested in, not the initial time, not the first time it reaches 50 meters. So we have the time, we use this distance and time to find the horizontal velocity, and then from horizontal vertical velocity we find the resultant velocity, and of course the angle.